Okay, I am back to make an amendment to this video 1998. Okay, question B says, show your setups the setup or describe the calculations necessary to determine the concentration of NaOH. And down here we said first we're going to find the moles using the grams of KHP to get the moles. Then we said at the equivalence point, moles acid equals moles base. A very, 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 very important thing was left out. Because KHP is a monoprotic acid, stoichiometrically, there is a 1-to-1 ratio, molar ratio, in between KHP and NaOH. Okay, NaOH. Okay, let me tell you what we really should have said down here. We should have said that moles of the acid, or maybe, I don't know, grams of the acid times the, I'm just kind of making this up. But maybe we should have said, if we'd have said this, it would have been better. So, not acid, but grams of KHP, in 1 mole of KHP. And right here, we're going to show that 1-to-1 ratio. 1 mole of KHP for every 1 mole of NaOH. So we could get, not moles of acid, but we could get moles of NaOH. Starting here, okay? So we could end up with that moles. Then we could take those moles and divide it by the volume of the NaOH used. Okay, so what's critical here, and I was just looking through some more things. Anytime you want to say this, you're going to, somehow or other, moles acid equals moles base. But somewhere, and that's true at any equivalence point, but somewhere you've got to let these people know that you know that there's a 1-to-1 molar ratio between the acid and the base. Okay, when you have a monoprotic acid and not barium hydroxide. So you want to be on the lookout for that barium hydroxide, because remember, you're going to get 2 moles of hydroxide for every 1 mole of that. Okay, so since you've come back, let's do a little pretend. Okay, let's say let's go through a different little scenario here. So let's say you've got this HA. It's solid, so you know it's going to be, it's monoprotic, and we're going to work all the way backwards, and we're going to figure out what its molar mass is. Okay? It's a solid, and we're going to titrate it and figure out what its molar mass is. We're going to titrate it with sodium hydroxide. Okay? All right, so how could we do that? So let's talk about the steps we're going to need to take first. All right, so we're going to take the mass of the HA solid. We're going to record that, and we're going to dissolve it in water, distilled water. Okay, and then we're going to add, we got to have something to see a color change. We're going to add phenolphthalein or some other indicator. Don't forget that. And then we're going to rinse the burette twice with NaOH. And then we're going to fill it with burette with NaOH, and we're going to record that initial volume. And then we're going to add that NaOH to that KHP or whatever that HA is, because they didn't tell us that really. And to this HA solution, you could put a beaker or a flask or whatever. You don't really have to say that. We're going to add it to the solution dropwise until a color change occurs. Stay with me. How about until it gets light pink, because we know that that's where we want to go. Then we're going to record that final volume. Okay, now, so what are the calculations that we're going to have to do? So how could we figure out how many moles of NaOH are? So what kind of measurements do we have to make, and how do we calculate that? So the moles, so in order to do that, we would have to have the final volume measurement. That's a measurement. The total change, if you just said how much you added to it, that's not a measurement. So measurements include the final volume of the NaOH and the initial volume of the NaOH. And then, so those are the measurements we'd have to make to get the moles. And then what calculation would we have to make? So remember, volume times molarity equals moles. So we would take the volume of the NaOH added so the volume of the NaOH that we added, and we would multiply it times the molarity, the moles per liter of the NaOH, okay? And that would give us moles. And we have clearly shown exactly how we're going to end up with moles, because this volume in liters, and if I use my bar, it would be even better. Okay, so we can show exactly how we're going to come up with our moles. Okay, so here we just talked about, to determine the moles of NaOH, what measurements and calculations. Now, how can we go about finding out the moles of HA that were consumed in this reaction? So what we have to do here is clearly show that 1-to-1 ratio, so that moles acid equals moles base at the equivalence point, but we have to be very clear that we show the stoichiometry of it. So HA plus NaOH yields NaA, whatever that salt is, plus H2O. There is a 1-to-1 molar ratio. So moles of NaOH are equal to moles of HA. Okay, now, what our goal is to figure out the molar mass. So what measurements do we have to have, besides the ones already talked about up here? What measurements do we have to figure out the molar mass? Well, we've got, what is molar mass? Molar mass is defined as grams per mole of a substance, and we just figured out moles of HA, so don't we need the grams of HA? Mass in grams of HA. So the measurement we need is the mass of the HA, and then the calculation then would be the moles, the mass of HA divided by the moles of HA that we calculated up here. And so that's how you could work that kind of problemo. Okay. Okay, so let's go a little further and say that what would happen if, when the student took the mass of this solid, what if it had water in it? What if it wasn't all the way dry? Okay, so if we look down here, where did we use that? If this molar mass is too high, and so let's just say it's supposed to be 2, and you said 4, and let's pretend that the moles were 4. So your molar mass would be 0.5. But let's say that it wasn't dry, so it came out as 4 grams. This would be grams, so that's what it's supposed to be. And then over 4 moles. So what's going to happen to your molar mass? This is grams per mole. So if the mass is too high, by this expression, then the molar mass would be too high. So you see, when you're asked for an error, you have to take it back to the equation where you used it and then see what's going to happen. And for me, the easiest way to do that is to always substitute in a number. I make up my own numbers and make them easy, and then I can substitute in. So now I absolutely know that I'm correct. So if the mass wasn't dry, then if the acid wasn't dry, then the molar mass would be too high. Therefore, if the acid wasn't dry, then the mass would be too high, and based on the equation, grams per mole for molar mass, then the molar mass would be too high. Okay, now, what if they said that the procedure called for 25 grams of water, here in dissolved water? If the procedure said put in milliliters of water, but the student used 35 milliliters of water. So what if they used too much water? What effect would that have? Well, where did we use this? Let's go find where we used these milliliters of water. The milliliters are the volume of the acid. So this would be the volume we put the acid in. Where is that? Nowhere. It didn't matter, because remember, we directly had the moles of acid, because we could take the grams of acid to get ourselves, but it didn't matter. We never used this, the milliliter. So when you're talking about dissolving a solid acid in water, how much water you put in there does not matter. So there was no effect, since the volume of the acid was never used in a calculation to determine the molar mass of the acid. Okie dokie.